我们知道它的由来跟脉络，还有它的目标，以及它目前遇到的困难，还有它目前所已经发展出来的成果，还有它未来的一个走向。那就由我来报告它的由来。那AMS 呢，它就是一个安装在国际太空站上的粒子物理实验的设备，然后它是由诺贝尔物理学家丁肇中博士在1995年开始提议的，然后这个计划呢动员了200多个人，还有31所大学院校，还有15个国家，所以是一个很庞大的计划。那它的主要目的呢是在探测宇宙中的那个暗物质跟反物质这样。那讲到 AMS 呢，一定要提一下丁肇中博士。那丁肇中博士呢，他在1976年的时候，获得诺贝尔奖，是因为他发现了一个新的粒子，叫做 J 粒子。然后，丁肇中博士他的 AMS 的诞生呢，在1976年他得诺贝尔奖之后，他在1983年就是，在那个欧洲强子对撞机那边，就是主持了一个 L3 detector 的一个计划，然后对 L3实验的计划，然后那时候有很多科学家嘛，就是有，反正这个实验也是一个很庞大的一个团队，然后他那时候就是希望说，就是能够升级这个实验，然后他就去找了美国能源部跟他要钱，但是美国能源部呢就拒绝了他的请求，然后他就很生气，就觉得非常难过，然后对，还拒绝，然后拒绝，真的很凶，然后那他就想说，这个实验呢就是涉及了很多人，然后又花了很多钱，但是最后那个他们就是面临到资金有点不足，于是他就开始想说，那是不是有没有其他的方法，就是能够做一个探测器，然后是用比较低廉的经费，那甚至它的体积可以比较小一点。于是呢，就是 AMS 一开始的想法，他的想法是说一开始呢，我们就大概用100多个人就好了，然后呢，它是做一个可以放在一张桌子上的机器，他当初是这样想的，于是呢，他就做了 AMS 这个东西出来，但是后来呢，他花了14年，花了15亿美元，然后呢，跟他讲的100多个人也差很多，他用了500多个人，然后用了16个国家、56个研究机构、500多个团队，然后呢，他是把机器放在桌子上没错啦，但是他放在了一个可以停下小型公共汽车的那个停车格这么大的一张桌子，然后那个光那个机器就重达了7吨，所以他也是离他目标有点蛮远的，然后它可以放出0.86特斯拉的时长，它是地球时长的17000倍，然后因为它本身放出来磁场很强，所以它必须要再花另外一半能量去抵消那个磁场，不然的话，它在太空站的时候就会飞来飞去，就是没有办法抵触这样。然后 AMS 它有一些大事迹啊，就是第一代 AMS 呢，在1988年6月是丁肇中博士要完成的出行，然后被发现号送入了太空中，但是什么都没有探测到这样子，然后但是至少他确定了说，把探测器送到太空中是一个可行的计划，是一个可以办得到的事情。然后过了几年之后呢，他们就发展出了第2代，那第2代的时候呢，就是在2011年5月16号，由奋进号这个太空舟载着它前往太空站开始执行它的任务。然后在2012年7月的时候，就有报道说它已经侦测到了181个宇宙的射线。最后呢，在2013年2月呢，他就发表了一篇 paper 证明说他们就是那个AMS 有侦测到了一些东西，然后就是显示说它的正电子跟电子的比是在0.5到350 GeV 之间，就是可以证明说有大量的暗物质，大质量的强互相作用的粒子同学，反正就是有侦测到一些东西。
不是啊，就是正电子比电子来的多。
对对。那我们来讲一下它的目标，我只是大概做一个大纲的简介。
The goal of AMS. The goal of AMS will use a unique environment of space to explore the mystery of the universe. And the forces they want to search are antimatter, dark matter, strange light, and space radiation environment. And we know there has 6 kinds of core: up, down, straight, trunk, bottom, and top. But most of the matter on Earth is made up of only up and down quark. So if we can find something is made up of up, down, and straight quark in space, it will be a totally new form of matter. And this is a goal of AMS in strange light.
，Hello everyone. My topic was about the obstacles that AMS faces, and from now on I will tell you about it. First of all was the technical problem of its own destruction. Since AMS was an incredibly sophisticated detector and probably the most sophisticated one that ever sent into space, and its entire project was led by, as I heard, a very tyrannical scientist, and who led, let's say, an incredibly huge team, and what was constructed to ISS, the International Space Station, which was the most distant laboratory ever. And the other technical problem of its construction is that was about the space shuttle, because originally NS was not designed to settle by space shuttle on ISS. It was designed to be carried by a one-time rocket, which was the original project was called Ares 5, but that project, Ares 5, was cancelled in 2009 because it was way too expensive than NASA expected. Although the space shuttle project was the most expensive one in the human history. So you can see in those photos, I don't have. Okay. You can see that originally NS was round-shaped, like a ball or something. That was meant to be settled in these types. And as you can see in the photos, they are all round shapes, not like space shuttle. But all these space shuttles you see here was even more expensive than space shuttle, so they spent a lot of time to resettle it into the cargo bay in the space shuttle. And right now, what I show you here is the other obstacles that most projects about space will face, is that the cost to send something into space. On top of this, you can see the Falcon Heavy, which was the expected expected rocket that will be the cheapest rocket ever, and since it can be reusable. But right now, the estimated cost to ever send something to space was at least $10,000 per kilogram, and back at the time of NS, the cost to send NS to ISS was estimated to be $18,000 per kilogram. So, these algorithms I used here was to use to calculate in a cheapest way, but the real number should be double as much as this. And as many people have mentioned, that the total cost was almost $150 million. And I want to make a small comparison about this event, because most people and most politicians called money was the greatest obstacles that all scientific project faces. But I don't say that is a question, because if we can see the film Gravity, its budget was even more than the budget that we used in the MS project. But although it's a scientific film, which does not have any real scientific effort, but it costs us more money than a real scientific project. So that's the whole idea. And the other idea why in 2009 the U.S. representative passed this bill of MS to the full House of Representatives. The reason they passed it because they knew that that project will be done by Space Shuttle instead of the old one, Artemis 5. And the Space Shuttle was the work of Lockheed Martin and Boeing. And Lockheed Martin and Boeing are one of the biggest arms dealer in the U.S. and they have very good ties and bond with the U.S. executive. And also the president back in 2008 was George Junior Bush, and he has a huge backdoor towards directly to Lockheed Martin. That's why they chose Space Shuttle instead of Artemis 5. So it has to my opinion, it has also more political issue that influence this project instead of technical issues. Thank you.
好，那我再来是讲 AMS 的成果。那这个成果其实大家都知道，它的成果是就找到比较多的正电子这样。他们把这个Alpha那个磁谱仪装到太空站以后，然后他们原先一开始的目标是要去寻找这个暗物质，然后反物质其实是因为当时那个时候刚好是非常热门，然后又可以测，所以他们就顺便就是一起走上去这样子。那我们莫忘初衷，我们要记得他原先的目标是要找这样的东西。然后它每1秒可以记录1000个宇宙射线，然后它的数据量产生量是每1秒是1个 Giga， 那这些数据会压缩成每秒300 KB 传回去控制中心。那他们虽然已经有测一堆这些 data， 但是他们数据量还不足以让理论学家去建构一个新的模型或者是一些其他的理论这样子，所以这地方要帮那个 AMS 平反一下，就是其实它一开始设计上它是想要用超导磁铁去做，然后可是后来是 发现说它会有一些泄漏，然后它又不方便去，因为在外太空，它又不方便去做一些液态氦的补充，所以它就只好就是勉强用那个一般的那种磁铁这样子。那所以它变成需要用时间去换取它的数据量。那我们未来可以期待说它会给我们比较多的 data， 然后让后面一些理论学家可以去建构它的模型这样。谢谢大家。
好，我们现在报告 AS 的未来，那我们就来讨论它 AS 的研究的目标的未来的可能性。好，第一个反物质，时光倒流。想要时光倒流，我就想到回到过去，然后回到过去就想到时光旅行。费曼他曾经研究这个狄拉克方程式的时候，发现，电子随着时间这样走下去，不会符合这个方程式。那如果我们把电子换成反电子，然后往另外一个方向前进，那它也会符合这个方程式。那费曼和他的老师还可以大胆的假设，其实整个宇宙是由同一颗电子，然后在这个时间轴之中来回走动，所以他们才会就是电子跟电子间是没有分别的。那这东西跟时光旅行有什么关系吗？其实没有关系，是未来很长嘛，对不对？搞不好它就是时光旅行的那个钥匙。好，那能源，因为这个物质跟